When we try to evaluate a definite integral, it's going to be very similar to what we do with an indefinite integral. It's just there's one extra step at the end. So we know this is a definite integral because of these two numbers, the 1 and the 4. Those are the limits of integration. In order to integrate, we just integrate the expression like we normally would. So 3x squared, the integral of that, we would raise the power to 3, and then take the coefficient divided by our new power. Minus 1 turns into x. If this were an indefinite integral, we would put the plus c at the end, but since it is definite, we are going to evaluate it from x equals 1 up to 4. And that means taking our expression, the x cubed minus x, and evaluating that from 1 to 4, means plugging in 4 first. 4 cubed minus 4. And then subtracting the value when we were to plug in 1. So 1 cubed minus 1. Gives me 64 minus 4 minus 1, which is 0. And so the value here will be 60. Let's try it a couple more times. First of all, with the integral from 0 to pi over 2 of 3 cosine x dx. So we integrate 3 cosine, and it is sine, whose derivative is cosine, that we'll evaluate from 0 to pi over 2. So first, we'll plug in pi over 2 and subtract the value when we plug in 0. Now, the sine of pi over 2 is 1, and the sine of 0 is 0. So this value is going to be just 3. And our last one, the integral from 1 to e of 1 over x plus e to the x dx. So we integrate 1 over x plus e to the x. The integral of 1 over x is natural log of x. The integral of e to the x is e to the x. And we'll evaluate this expression from 1 to e. That's going to mean plugging in e first, natural log of e plus e to the e. And then we plug in 1, natural log of 1 plus e to the 1. And simplify. Natural log of e is 1. E to the e, even though it looks weird, it's still a number, and we'll leave it there. Natural log of 1 is 0, and e to the first is just e. So our expression will simplify down to 1 plus e to the e minus e.